Welcome back, dear students, in another video. In this video, we'll learn what is mole fraction and how we can connect it with the other concentration terms which we learned in the previous videos. That is the molarity and molality. So first, let's start with the mole fraction. What is mole fraction? As you can see here, I have written it. It is basically the mole ratio of a solute or solvent present in a solution to the total number of moles present in the solution. That means what? That means we need to calculate the number of mole or the mole of a solute or a solvent, whichever you want, you can measure. And that will be divided by the total number of moles present in the solution. Okay, so this is the idea of this mole fraction. Now let's see what does it mean actually. Say for example, you are taking a solution with only one solute and one solvent. So we are writing that let's start with the molecular mass or the molar mass of a solute. Let's take it as WA. Sorry, not WA but MA. This is the molar mass of a solute. Similarly, we can take the molar mass of a solvent, which we are taking as MB. Now, the mass of solute, we are taking it as WA, and the mass of solvent, we are taking it as WB. So once we have the molar mass as well as the mass of individual components, either solute or the solvent, we can easily calculate the number of moles that we have done. Therefore, number of mole for solute can be calculated as mass by molar mass. Let's say this one is our Na. So similarly, we can calculate the number of mole of the solvent. So what it will be? Number of mole for solvent will be is equal to mass divided by molar mass. Okay, and let's say this is NB. So here Na and NB, they are nothing but the mole number for solute and for solvent. So when we have this one, now if we follow the definition, what they are saying we need to take the ratio of either the solute, the mole ratio of this solute or the solvent whole divided by the total number of moles present in the solution. So if we are following this statement, we can write the mole fraction for solute. It is nothing but the mole ratio of solute. So we are calculating for the solute. So how we can write that? We need to put the mole number of solute whole divided by total number of moles. So in solution, what we have? In solution, we have solute as well as the solvent. So when we are dividing it with the total number of moles, that means we need to consider the number of mole for the solute plus number of mole of the solvent. Therefore, in the denominator, we are supposed to write it like this. So here this is our mole fraction for the solute. Similarly, if you want to write it for the solvent, you can write it like this. In this case, we need to take in B number of mole of the solvent whole divided by Na plus Nb. So in that way, we can easily calculate the mole fraction not only for the solute but also for the solvent. Okay. Now once you understand this mole fraction, then we'll move on to find out the relation between this mole fraction with molarity, and second I will check it for the molality. Okay, so let me erase this one. So first we are going to determine the relation between molarity with mole fraction. Okay, so what to do? Let's see how we can define it. I hope that by this time you know how to express the concentration of a solution in terms of the molar solution or the molarity, and just now we have learned what is the mole fraction and how to calculate it. So let me write it first, all the parameters what we are going to use. First, mass of, so that we can avoid any kind of a mistake. Mass of solvent, let's say, okay, first let me write the solute. That one, WA. Mass of solvent, let's say this is WB. Okay. Now, molar mass of solute, let's say this one is M1. I am trying to follow the same trend. A stands for the solute and we'll take the B for the solvent. So second one, molar mass of solvent, that is equal to MB. So we can easily find out number of mole for solute, which is nothing but, we can easily calculate if these values are given, WA divided by molar mass of the solute, which we are taking as MA, say for example. Okay. Similarly, number of mole for solvent, we are taking it as MB. I hope you understand how we can calculate the MB value by dividing the mass by the molar mass. Okay, so these are the things which we are going to use for the for finding the relation between the molarity and the mole fraction. So to find out this relation, first we need to use one information, and I believe that all of you know what is that relation. This is very simple thing, that is density. We know density. I am going to use the rho for this. Okay, that is nothing but the mass by volume. So same thing we can write as volume is equal to mass by rho, which is our density. So how we can get the value of the mass for a given solution, or given solution of a definite volume? So mass means what? It means the mass of solute plus solvent. So how we can write this one? We can write this one simply like as it is given here, the mass of solute and solvent. So I will write it simply WA plus WB divided by rho. Now you see one thing, from this relation, from here we can write one thing, WA, that is nothing but number of mole into molar mass. Okay, very simple. So now instead of writing the mass with the WA and WB, I am going to use this part, that is the number of mole into molar mass. So if I am doing the change, it will become Na into Ma for the solute plus Nb mass of molar mass of B. Okay, let me put in number, this is 1. Now, what we know about the molar solution? We know the concentration in molarity can be expressed as number. This one we are calculating for the solute. That's why I am writing the number of mole of a solute in the given volume of a solution. Given volume of solution. In this case, I am taking it in ml unit. So if we are writing it in ml unit, then you know that we need to multiply numerator by 1000. So this is what we know. Now, this volume is what? This is the volume which we have calculated here. So simply, I will replace this denominator with this value. So if we are doing it, then what we'll get? We'll get the Na multiplied by 1000 whole divided by the volume. So this is the volume Na Ma plus Nb Mb whole divided by the density. So here, let me write it by using equation 1. Okay. Here, how I am writing it? First, I calculate the volume and then I substitute that value in this equation. So once it is done, then remaining things are very simple. Let's see, let me simplify it a little bit. So it will become Na into 1000 into density, right? This one will go up, whole divided by Na Ma plus Nb Mb. Now we need to do one trick. What is that? We need to divide the numerator as well as the denominator by Na plus and Na plus Nb. Okay, Na plus Nb. So if we are dividing it, then how it will become? It will become Na plus Nb. I hope you have understand why I am doing it like that, because we are here to find out the relation between the molarity and the mole fraction. So if we want to use, or if we want to get the mole fraction, then definitely we need to have this kind of a thing. Then only I can write this is the mole fraction of the solute. That is the reason why I am dividing numerator as well as the denominator by Na plus Nb. That's the reason. So after that, let me erase this side a little bit. Otherwise, it will be misleading to some extent. It will mix up. Okay. Fine. So remaining thing will remain as it is into density whole divided by. Now you see Na divided by Na plus Nb into molar mass of Ma in the solute plus Nb divided by Na plus Nb multiplied by Mb. Now what is this? These are nothing but the mole fraction. So we can write this form in this side, as I don't have that much space here. So let me write it here by dividing and denominator by Na plus Nb. Why I am writing it? So that you can understand after some time also. When you are watching this video again, you can understand that how we are writing this one. Okay. So here if I am going to write, then molarity will become is equal to, what is this? Na by Na plus Nb. That is the mole fraction of solute. Okay. Multiplied by 1000 into density whole divided by, this is the mole fraction for A, I mean the solute, multiplied with Ma plus mole fraction of solvent, that is the B into Mb. So this is the relation between the molarity and the mole fraction. If you want to simplify it little bit, you can also write this one is equal to, mean I want to get this one in terms of mole fraction of solute. Then what I can do, I can write it like this, mole fraction of A multiplied by Ma plus mole fraction of B, that can be written as 1 minus mole fraction of A. So now here you can see only we have the molar mass of the solvent, other things all are given in terms of solute. So you can use this one very easily, both are the synonymous. Now in this regard, I forget to mention you that when we discussed about the mole fraction, always remember the mole fraction, whatever you are going to get, that always should be is equal to 1. And that is the reason how I change the mole fraction of B in this form, 1 minus mole fraction of A. So this equation, this mole fraction concept, basically that cannot be used only for the solution. It can be used for any kind of a mixture having n number of components. Okay. In that case, how it will become? It will become like this: XA plus XB plus mole fraction of C plus dot 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 dot, that is equal to 1. So if we are going back to the mother equation, say you want to calculate the mole fraction of a component C, where in the mixture you have n number of components, then you need to calculate the number of mole for this particular component divided by all the number of moles present in the mixture. Like that it will be continuous. Okay, but here in solution we are only considering we have one solute and one solvent. That's why this one reduced down to this form. So now I hope you understand how we are able to find out the relation between the molarity and the mole fraction. So once you are done, second we'll see the relation between the molality with the mole fraction. That is again quite simple. Here I am going to, I hope I will be able to derive it within 5 to 10 minutes, not more than that. So I am erasing these things. The other things will remain the same. Okay. And I have to replace it, the molarity with the molality. That's it. Okay. Which is the small m we are using. Now, how to get the relation between the molality and the mole fraction? In this case, you remember that we need to take the ratio of mole fraction of solute and mole fraction of our solvent. Okay. Now this is what, this one we know basic. Let me write it. How to get the mole fraction of A and B? Simply let me write one extra line so that you can understand it clearly. This is how to get the mole fraction of solute, that is our A, and mole fraction of B. Right? This one we have understand just now. So if we are simplifying it, we'll see that this one will become in A by number of mole of solute by divided by number of mole of B. Okay. Now, how to get the value of mole? This one we can obtain like this, or here I am not writing. Number of mole mean the amount number of mole can be written as you can see here, Na is equal to Wa by molar mass of the solute. So simply I am writing it in that way to make it simple. Wa given mass whole divided by the molar mass, and this is how we will get the number of mole. Similarly, for solvent we can write it like this. So if we are simplifying, What we'll get? We'll get the given mass of solute multiplied with the molar mass of solvent whole divided by WB into MA. Okay, so we can write mole fraction of this solute by mole fraction of solvent, and if we are simplifying it, we'll get this relation. Now here you can see we have everything in our left hand side, that is the mole fraction, but there is nothing which is associated with the molality of the solution. Now how we can get this side, the molality? To get that, we need to do one trick. We need to multiply both sides with a definite factor. What is that? Say for example, if we are multiplying it with 1000 by molar mass of solvent. If we are doing it, then definitely I need to multiply this side. So if we are multiplying, it will appear like this: WB into MA multiplied with 1000 divided by MB, molar mass of B. Okay, this is understandable. So here what I have done, multiplying both sides with 1000 divided by molar mass of the solvent. Okay, there is a definite reason, so that I can bring the molality unit. So after doing this multiplication, you can easily see that this one cancel out. Okay, so what is left over? Here we have, let me rearrange it little bit. Molar mass, given mass of a solute divided by molar mass of the solute. Okay, whole divided by mass of the solvent into 1000. So this one nothing but number of mole of solute in given mass of a solvent, WB. This is what? This is nothing but molar solution. Okay, so here I am just going to write this molar with another color so that you can identify that this is nothing but the concentration, molar concentration. Now you can see molar solution get connected with the mole fraction. So if you want to simplify it further, if you want, you can keep it like this. Otherwise, if you want, you can simplify it a little bit more. How? Say, let me use this side. So what we can write? We can write molal is equal to mole fraction of XA by XB into 1000 by molar mass of the solvent. If you are not happy with the mole fraction of the solvent, if you want to express it in terms of solute, you can simply write it XA, mole fraction of A multiplied with 1000 divided by 1 minus mole fraction of solute, as we have done in the previous case, into MB. So this is the relation between the molality with the mole fraction. Okay, so I hope all of you have understand how we can find out the relation between the various concentration. Last video we have shown you how we can connect molarity with molality. Today we have learned what is mole fraction, how to calculate that by knowing the amount given of a solute or a solvent, whichever, and knowing their molar mass. If any one of them are missing, then it is quite difficult to find it out. So once it is done, then we checked how we can connect the molarity. Remember molarity, capital M, with the mole fraction. In that case, we used the density. Okay, and in this case, only the trick is to multiply both sides with this factor. And I hope by this time you have understand why we are multiplying it with the 1000 divided by molar mass of B, so that I can easily convert it to the molal solution. And this is the final relation between the molality with the mole fraction. Okay, I hope all of you have enjoyed and understand this calculation interconversion from one unit to another unit. And in the next video onwards, we'll solve different numerical problems associated with the concentration. By that time, you can go through these videos, you can check it how these things are coming, so that when we are going to solve the numerical problem, it will be quite easier for you from where and how we are using those relation or the equation to convert one concentration to the another type of concentration. Okay, so that's all for today's video, and in the next video we'll solve some numerical problem. Thank you for watching this video.